Right now, an algorithm might be deciding if you get a mortgage
Hmm.
or, filtering your resume for a job you desperately want, or even routing a 50-ton commercial truck through the exact neighborhood where you live.
Yeah, which is a terrifying thought when you really break it down.
It is. And we like to think of these machines as these cold, objective calculators, right? You punch in the data, and the system produces a clean, mathematically pure result.
Completely untethered from human messy reality.
Exactly. Untethered. But the source material for our deep dive today warns that the exact opposite is actually true.
Right.
We're looking at a presentation titled Introduction to Responsible AI, and it's by Manny, who is a security engineer at Google Cloud.
And I think it is so vital to pause right there on that title, security engineer.
Why is that specific title so important?
Because when a security professional looks at a system, they aren't looking at, the shiny marketing brochure. They are looking at the attack surface. They're building threat models. They inherently assume the system is going to fail or be exploited or operate in some wildly unpredictable way.
They're looking for the cracks in the foundation.
Exactly. Their entire job is to engineer structural mitigations against catastrophic outcomes.
Mm-hmm.
So when a security engineer talks about responsible AI, we are not talking about an abstract feel-good philosophy class.
No, it's not a corporate buzzword.
It's critical infrastructure protection.
Right. So, welcome to the deep dive. Our mission today is to unpack what this concept of responsible AI actually means in the trenches of development.
Because it really is a rigid operational framework that dictates every single decision at every stage of a project.
And I think the most provocative takeaway from this material, the thing that really shifts the paradigm for you as the listener, is the realization that artificial intelligence is fundamentally, inescapably human.
Yeah.
Okay, let's unpack this. We have to start by establishing the baseline of how deeply embedded this technology already is, and why the whole objective calculator myth is so incredibly dangerous.
Well, the source text really grounds us in the reality of the invisible AI we interact with daily. It points to things like traffic predictions, weather forecasts, TV show recommendations.
Right, the stuff you don't even think about anymore.
Exactly. Now, obviously, to a tech-literate audience, the fact that a streaming service uses an algorithm is not breaking news.
I mean, we'd hope not.
Right. But the text is using these examples to highlight a massive shift in our baseline operational expectations. These systems have faded entirely into the background.
They're just the foundation of our daily logistical routines now.
They're ambient.
Ambient. I like that word. We don't even conceptualize them as artificial intelligence anymore. Like when your Maps app rewrites you to avoid a sudden closure on the highway, you don't marvel at the real-time ingestion of thousands of telemetry data points, right?
No, you just take the next exit and complain about the delay.
Exactly. And the text provides an analogy to describe this transition that I think really frames the stakes. It states that as these integrated AI tools become the standard, technologies that lack AI are starting to feel inadequate. This is, it's like having a phone that can't access the internet.
And think about the mechanics of that inadequacy for a second.
Okay.
A flip phone without a data connection still fulfills its original primary function perfectly well, right?
Yeah.
Makes phone calls.
Sure.
But in a modern context, it feels entirely broken.
Because your environment has fundamentally evolved.
Exactly. You, as the user, now expect continuous contextual awareness from your devices. You expect the device to pull data from a global network to solve immediate, localized problems.
Like finding a coffee shop or checking a flight status.
Right. So the text is arguing that an application without an underlying machine learning model, something to anticipate user needs or adapt to unstructured data, is going to soon feel just as isolated and functionally obsolete as a phone without a browser.
The expectation is no longer just computation. It's comprehension.
Comprehension. That's a great way to put it.
The text points out that we are building systems that can see, understand, and interact with the world in ways that were unimaginable just a decade ago.
And we are moving from tools that require us to learn their rigid syntax to tools that are designed to learn our messy reality.
But here's the trap, right? Because these systems are so powerful and they operate with such seamless speed, we fall into this cognitive illusion.
The illusion of the machine.
Yeah. We assume the machine itself is playing the central decision-making role. We picture the AI sitting in a server farm somewhere, objectively calculating the optimal truth.
And that right there is the core vulnerability in how the public interacts with this technology. The illusion of the autonomous, objective brain.
So what's the reality?
The reality, as outlined in the Google Cloud presentation, is entirely different. Humans are the central processors of every AI system.
Always humans. Always. The text explicitly outlines that human beings collect the data. Human beings create the training sets. Human beings control the deployment architecture.
And they dictate the exact context in which the AI is allowed to operate.
Precisely. The machine is essentially a mathematical echo of those human choices.
Let me try out an analogy here, because I know the common metaphor is that training an AI is like, raising a child.
Right. We hear that one all the time.
But I don't think that captures the structural rigidity of what we're actually talking about.
Oh, so?
It's more like training an autonomous vehicle using a warped map. If human engineers feed the car a map where all the roads are drawn, say, 5 degrees to the left,
Okay, I see where you're going.
the car's internal logic is going to function flawlessly. The code itself isn't broken. It will execute its driving algorithms perfectly, and it will drive straight into a ditch every single time.
Because the AI doesn't know the map is warped.
Exactly. It assumes the foundational reality it was handed is the absolute truth. That is a much more accurate mechanical framing. The algorithm is just an optimization engine. It ruthlessly optimizes for the patterns it finds in the environment you provide.
So if we look at the first stage mentioned in the text collecting and creating training data, we have to realize that data collection is not this passive, objective harvesting of the universe.
No, not at all. It's a highly curated, highly subjective process.
Human data scientists are deciding what variables are even important enough to measure in the first place.
And they decide what historical time frame is relevant. Plus, human annotators often label that data, which injects their own subjective interpretations directly into the data set.
So by the time the machine even sees the data, it's already been filtered through layers and layers of human editorializing.
Exactly. And then we get to the deployment and the context.
Right, because the machine doesn't wake up one morning and decide its life's purpose is to filter resumes for a tech company.
It doesn't have ambition.
A human product manager decides to point this pattern recognition engine at a pile of PDFs and tells it to find the quote-unquote best candidates.
Based on the historical hiring data of that specific company.
Right. And the text says something here that really anchors this whole concept. It says, essentially, human decisions are threaded throughout our technology products, and every time a person makes a decision, they're actually making a choice based on their own values.
The phrasing threaded throughout is very deliberate there.
It means you can't just pull the thread out.
Exactly. The human element cannot be cleanly decoupled from the compiled code. The values of the development team are fundamentally compiled into the model's architecture.
Wow.
And because of this inextricable link, the source text issues its primary warning, which is that AI is not infallible.
Because humans aren't.
Right. A system built on the subjective choices of fallible humans carries inherent structural risks. Developing responsible AI isn't just about making the chatbot polite.
No, it's about actively hunting for the limitations, the blind spots, and the unintended consequences that have been hard-coded into the system through our own human bias. Which brings us to a massive shift in how we need to view these tools. The text states, technology is a reflection of what exists in society.
The mirror of society.
Yeah. If we are using a warped map, if society has historical flaws, systemic inequalities, or just cognitive blind spots, those flaws are recorded in the historical data.
And therefore the technology inherits those vulnerabilities.
Inherited risk, that's what you'd call it in security, right?
Yes, from a security perspective, this is the exact threat model of inherited risk. If you train a model on historical data, you are literally training it to perfectly replicate the past.
But the source text pushes this even further. It warns that without rigorous practices, AI doesn't just replicate existing issues or bias.
It amplifies them.
Amplifies them. Let's really drill down into the mechanics of that amplification, because bias is a word that gets thrown around loosely in pop culture, but in machine learning, it is a very specific mathematical phenomenon. How does a subtle human bias scale up into a catastrophic system failure?
We have to look at the intersection of three things: scale, speed, and mathematical confidence.
Okay, lay that out for me.
Imagine a human loan officer. They might have an unconscious bias that makes them, say, slightly less likely to approve loans for applicants from a specific zip code.
Right.
Now, that human can only process maybe a few dozen applications a day. The bias is a flaw. It's terrible, but its blast radius is contained by the physical limits of human labor.
A human gets tired. They go home at 5.
Exactly. Now, you take 10 years of that bank's historical loan data to train a predictive AI model.
Oh, I see where this is going.
The model analyzes the data and finds a statistical pattern.
Oh.
Applicants from this zip code are rarely approved.
But the AI doesn't understand sociology or history or redlining.
Not at all. It only understands mathematical correlation, so it encodes that pattern as a rule for success.
Because to the AI, the historical data isn't biased. The historical data is the ground truth of the universe.
Right. It assumes the human past is the mathematically ideal future. But here is where the amplification happens. When you deploy that model, it doesn't process 50 applications a day
It processes 50,000 applications a second.
across the entire country. And unlike a human, who might occasionally bend the rules or feel empathy for a specific applicant sitting in front of them,
The machine doesn't feel empathy.
the machine applies that biased mathematical rule with absolute, untiring consistency.
So a localized, subtle human flaw has been automated into an impenetrable, instantly scalable barrier.
The bias has been amplified by the raw processing power of the system itself.
Man, that's heavy. But I want to challenge this narrative slightly. Or at least, play devil's advocate regarding the scope of the problem.
Go for it.
It makes complete sense that we need intense ethical frameworks for high-stakes environments. A loan approval algorithm, medical diagnostics, criminal justice software. These are life-altering decisions.
Absolutely.
But not every AI is doing that. What about the mundane, everyday enterprise tools? Does an AI that just, optimizes the supply chain or summarizes internal meeting notes really require a massive, heavily engineered responsibility framework?
It is a very common blind spot in enterprise development to assume that low-stakes use cases are somehow exempt from ethical scrutiny.
Because they seem boring.
Right, because they're boring. But the source text explicitly shuts this down. It warns that even seemingly innocuous AI use cases, or those built with entirely good intent, can cause massive ethical issues or unintended outcomes if responsible practices aren't applied.
Okay, walk me through that. How does a tool with purely good intent doing something incredibly boring turn into a threat vector?
To understand this, we have to look at how machine learning models are directed, specifically through something called a cost function.
A cost function.
Yeah. When you build an AI, you have to give it a mathematical goal to optimize for. And the cost function essentially penalizes the AI when it makes a mistake relative to that goal.
Okay.
Let's take the classic, seemingly innocuous example, optimizing a delivery route for a massive fleet of commercial trucks.
Right. The intent is universally positive, right? Save fuel, reduce carbon emissions, lower operational costs, get packages delivered faster.
That sounds like a pure operational win.
Totally. Where does the harm come in?
The harm emerges from what the engineers fail to include in the cost function.
Ah.
If the algorithm is told to ruthlessly optimize solely for speed and fuel efficiency, it will find the mathematically shortest path between 2 points.
Okay, but what's wrong with the shortest path?
Well, it might realize that rerouting heavy commercial trucks off the main highway and straight through a quiet residential neighborhood or a school zone shaves 45 seconds off the route.
Oh, wow.
The AI isn't malicious. It doesn't hate the neighborhood.
It doesn't even know it's a neighborhood.
Exactly. It simply wasn't given a mathematical variable that penalizes routing heavy machinery near pedestrians or schools.
So the omission of a variable is where the unintended consequence lives.
Exactly. The engineers had a good intent, but they applied a dangerously narrow optimization metric. They failed to build a responsible framework that evaluated the broader societal context of the deployment.
And the result is a massive increase in noise pollution, infrastructure degradation, and physical danger to a specific community.
All for 45 seconds. And this is why the text emphasizes that responsible AI is required across the board. The very nature of machine learning is to find edge cases in your logic and exploit them to achieve its goal.
So if human safety and societal well-being aren't explicitly coded into the parameters of success, the AI will confidently trample over them to save a few seconds.
It absolutely will.
That mechanical reality, the idea that the AI will optimize exactly what you tell it to at the expense of everything you forgot to mention, really highlights why the stakes are so high.
Yeah, it leaves zero room for unstated assumptions.
Which logically brings us to the next problem. If bias amplification is this mathematical certainty, and if even innocuous tools can cause neighborhood-level harm, why is the industry still arguing about this?
That is the million-dollar question.
Right, why isn't there a global standardized rule book? Why hasn't an international standards body just published the definitive checklist for AI ethics that every developer has to pass before compiling their code?
Well, a universal checklist is the dream of every compliance department on Earth. But the source text explains why that is a total fallacy.
A fallacy.
Yes. It explicitly states that there is no universal definition of responsible AI, and there is no simple formula or checklist for how it should be implemented.
But why? From an engineering perspective, we use checklists for everything else. A checklist works great for building an airplane. You check the rivet torque, you check the hydraulic pressure. Why doesn't it work for a neural network?
Because a checklist is static, and artificial intelligence is fundamentally dynamic.
Okay, break that down.
A checklist is designed for a deterministic system, meaning if X happens, do Y.
Predictable.
Highly predictable. But machine learning models are probabilistic.
Yeah.
They are constantly interacting with evolving, unstructured data in totally unpredictable environments.
So the context is always shifting.
Constantly. What constitutes a safe output for an AI generating medical summaries is vastly different from what constitutes a safe output for an AI generating dynamic video game dialogue.
Oh, I see.
If you try to create a universal checklist that covers both of those use cases, the rules become so vague that they are operationally useless or so rigid that they stifle any actual utility.
So the text notes that because of this complexity, organizations have to develop their own AI principles that reflect their unique mission and values. And I mean, on the surface, that makes sense. A hospital's core mission is very different from a logistics company's core mission.
Right.
But let's look at the systemic risk here. If we rely on every individual tech company to invent its own ethical principles, aren't we just letting corporations grade their own homework?
It certainly looks that way.
Because if a company's primary unspoken value is just moving fast and monopolizing a market, they will just write principles that justify their aggressive behavior.
Right. That is the precise vulnerability of industry self-regulation, and it is a massive point of friction right now globally. If principles are just marketing copy designed to provide cover for reckless deployments, the entire ecosystem becomes incredibly fragile.
So how does the source text address that?
It provides a counter-argument to this fragmentation. It notes that while the specific implementations vary wildly depending on the organization's mission, if you analyze the frameworks across the industry, you see a convergence.
A convergence around what?
A core set of operational requirements. The text highlights 4 common themes that consistently emerge across these diverse frameworks.
Okay, let's list them. Transparency, fairness, accountability, and privacy.
Right.
Now, these words sound great in a press release, but I want to dissect what they actually mean as hard engineering constraints.
Let's do it.
Let's start with transparency. In the context of a deep neural network, a system that literally operates as a black box, processing millions of weights and biases in ways that even its creators can't fully visualize, what does transparency actually mean?
It's a great question. In a machine learning context, you have to separate transparency from interpretability.
Okay, interpretability meaning?
True interpretability would be looking at a massive neural network and understanding exactly why node 4000 fired instead of node 4001.
Right.
And that is often mathematically impossible right now.
So we can't truly interpret it.
Not at that granular level. So transparency has to be achieved at the systemic level.
What does that look like in practice?
It means being absolutely clear with the user about the nature of the interaction. Are you talking to a human or a bot?
Oh, simple disclosure.
Exactly. What specific data sets were used to train this model? And most importantly, it involves the pursuit of explainability.
Explainability.
Yeah. If an enterprise AI denies a vendor contract, the system must be engineered to provide a human-readable rationale outlining the key factors that drove the statistical probability of that denial.
Because without explainability, the system is just like an oracle handing down unchallengeable verdicts.
And that is entirely unacceptable in an enterprise environment.
Right. You can't just tell the CEO, the black box said no.
Exactly. You need the receipts.
Okay, so the second pillar is fairness, and we touched on this with the loan officer example earlier, but fairness isn't just a matter of deleting the race or gender column from your spreadsheet, is it?
No, and that is a critical misconception that catches a lot of developers off guard. Simply blinding an algorithm to a protected class does not make it fair.
Why not? If it doesn't know the race, how can it be racist?
Because of something called proxy variables.
Proxy variables. Okay, explain that.
If you remove race from a data set, but you leave in zip code, income level, education history, and purchasing habits, a sophisticated AI will mathematically reconstruct the concept of race through the correlation of those other variables.
Whoa, so it figures it out anyway.
It doesn't know its race, but it uses zip code as a proxy to execute the exact same biased pattern.
So the AI essentially redraws the lines of discrimination on its own because the underlying societal data still contains the shape of that discrimination.
Precisely. The shape is still there. Which is why the source text views fairness not as a passive state of being colorblind, but as an active, adversarial engineering process.
Adversarial, like you're fighting the AI.
You're red teaming your own models. Data scientists have to aggressively test the system against diverse data sets to actively look for disparate impacts.
Like, does this voice recognition model have a higher error rate for people with certain accents?
Exactly. Or does this facial recognition system fail when the lighting conditions change for different skin tones? Fairness is a continuous cycle of testing, identifying proxy bias, and recalibrating the model to mitigate it.
That sounds like an exhausting, necessary grind.
It is. It's constant vigilance.
Okay, so the third pillar is accountability. In a system where the machine is dynamically learning and generating novel outputs, who holds the bag when it makes a catastrophic error?
That's the crux of it. Accountability is the structural mechanism that forces organizations to remember that AI is a tool, not an autonomous agent.
The humans are in charge.
Always. The text emphasizes that humans control the deployment. Therefore, accountability means establishing rigid governance structures before the AI is ever turned on.
So if a generative AI model hallucinates a fake legal precedent and a lawyer uses it in court...
The organization cannot just shrug and say, well, the math did it.
Right, bad math.
Exactly. Accountability requires clear lines of ownership within the company, established protocols for human override, and a defined process for remediation when the system inevitably behaves in an unexpected way.
It is about maintaining a human chain of command over probabilistic software.
Chain of command is the perfect way to phrase it.
And the fourth theme is privacy, which frankly feels like the most acute threat for the average person listening to this. These models are insatiable data vacuums.
They absolutely are. And privacy in the era of machine learning is a fundamentally different challenge than privacy in traditional software.
How so?
Well, traditional software stores your data in a database. If you want to delete your account, they delete your row in the database. Simple.
Right, you're gone.
But a large language model doesn't just store data. It ingests it and bakes it into its neural weights.
Oh, it digests it.
Yes. So, if an AI is trained on sensitive corporate communications or personal medical records, there's a massive risk of data memorization.
Meaning the model might just inadvertently regurgitate that private information when prompted by a totally different user.
Exactly. It might just spit out someone's social security number because it memorized that specific sequence of numbers during training.
So privacy isn't just about securing the database with a firewall. It's about ensuring the model itself doesn't become a vector for data leakage.
Right. Privacy principles dictate rigorous data sanitization before training ever begins. It mandates techniques like differential privacy.
What's differential privacy?
It mathematically guarantees that the model learns the broad patterns of a population without memorizing the specific data points of any individual within that population.
Wow, okay. So we have these four pillars: transparency, fairness, accountability, and privacy. These are the theoretical guardrails. But theory is cheap, right? The source text transitions into a concrete case study here, explaining how a massive organization like Google actually attempts to operationalize these concepts.
Well, Google's overarching stance is framed around building AI that is, for everyone, accountable, safe, respects privacy, and crucially, for a tech company driven by scientific excellence.
But the operational key is a phrase the text uses: responsibility by design.
Yes. Incorporated responsibility by design into our products, and even more importantly, organization.
Let's look at the mechanics of by design, because it implies a shift in where the ethical work happens on the timeline of a project.
In the security world, we talk about shifting left.
Shifting left.
Yeah. If you look at a project timeline moving from left to right, from brainstorming on the left to coding in the middle to deployment on the right.
Okay, I'm visualizing the timeline.
Security used to be something you bolted on the very end on the right.
Like an afterthought.
Exactly. That is incredibly inefficient and dangerous. Shifting left means integrating security protocols at the earliest brainstorming stages.
On the far left.
Right. Responsibility by design is the shift left concept applied to AI ethics.
Meaning you don't build the entire neural network, spend millions of dollars on compute power to train it, and then hand it to an ethics committee right before launch to see if it's biased.
Because if the ethics committee finds a foundational flaw at that stage, you have to throw the entire multi-million-dollar model in the trash.
Which no company wants to do.
No. So responsibility by design means that before a single line of code is written, the team is evaluating the data pipeline for bias. They are designing the user interface to ensure transparency. The ethical constraints dictate the architecture of the system from day one.
The text ties this back to that human element we discussed earlier, noting that every decision point introduces human values. And it provides a highly specific example that I find really fascinating.
Let's see example.
It says, whether it's a decision to use generative AI to solve a problem, as opposed to other methods, that person introduces their own set of values. Let's stop and analyze that. Why is the mere choice of using generative AI considered a profound ethical decision?
Because generative AI, like massive language models, is not a universal hammer for every nail.
Right.
It is a highly specific, highly volatile tool. These models require staggering amounts of energy to run, creating a massive environmental footprint.
Power grids are already feeling it.
Absolutely. They are computationally expensive, which drives up operational costs. And inherently, they are probabilistic engines that guess the next most likely word.
Meaning that they're structurally prone to hallucinations.
Yes, presenting confident falsehoods as absolute fact.
So if an engineer is tasked with building a tool to, say, classify incoming support tickets into 3 basic categories,
Okay.
and they choose to use a cutting-edge generative AI model instead of a simple deterministic rules-based script, they are actually making a value judgment.
A huge one. They are prioritizing technological novelty over system stability. They are choosing to incur a massive environmental and financial cost for a problem that could be solved with a fraction of the resources.
And they are introducing the risk of unpredictable hallucinatory outputs into a system that requires absolute reliability.
Exactly. That decision is a failure of responsibility by design. The responsible approach requires evaluating the specific requirements of the problem and selecting the least complex, most reliable, and most secure tool for the job.
Not just the flashiest one.
Exactly.
Okay, we've covered the philosophy, the threat models, and the engineering design process. Let's pivot to the business reality.
The bottom line.
Right, because in the enterprise world, you can talk about ethics and responsibility all day, but if it doesn't align with operational success and profitability, it just gets sidelined.
It becomes lip service.
But the text makes the case that these concepts are inextricably linked. It argues that ethics actually guide AI design to be more beneficial for people's lives.
It frames responsibility not as a regulatory burden, but as a utility multiplier.
A utility multiplier.
Yes, a model that is actively engineered to be fair and transparent is simply a higher quality, more robust piece of software than a model that is brittle and biased.
The text drives this home with a specific formula for enterprise survival. Google notes that building responsibility into their deployments makes better models and builds trust with our customers and our customers' customers.
That phrase is everything.
Our customers' customers. That is the B2B2C pipeline. Let's break down why that specific chain of trust is the actual economic engine of the AI industry.
Okay, let's frame it as an enterprise deployment scenario. Imagine you are the chief technology officer of a massive global airline.
Okay, I'm the CTO.
You purchase a sophisticated AI routing and customer service system from a cloud provider.
Right.
You are the customer.
Right, I'm buying the software.
You need to trust that the cloud provider engineered a secure, accountable system. But your trust isn't the ultimate metric here. No. The ultimate metric is the passenger trying to rebook a canceled flight during a snowstorm. They are the customer's customer.
Ah, okay. So if that passenger interacts with the AI chatbot, and the AI is opaque, unhelpful, or hallucinates a fake company policy that denies them a refund.
The passenger doesn't care about the cloud provider's underlying neural network architecture.
They don't even know who the cloud provider is.
Exactly. The passenger blames the airline. The brand damage is immediate and localized to the enterprise that deployed the tool.
So if the end user loses trust in the fairness or reliability of the system, they will bypass it, complain publicly, or abandon the service entirely.
And suddenly, the cloud provider's technology becomes actively harmful to the airline's core business.
And the source material explicitly warns about the fallout of this shattered trust. It says that without it, we run the risk of AI deployments being stalled, unsuccessful, or, at worst, harmful to stakeholders. Let's look at the mechanics of a stalled deployment in the enterprise tech space.
A stalled deployment is a catastrophic financial event.
Really? Just stalled?
Yes, because we are talking about projects that involve massive capital expenditure. Procuring data, renting compute clusters, dedicating hundreds of engineering hours.
Millions of dollars.
Millions. If an organization pushes forward without a responsibility framework and they discover a critical privacy vulnerability or a massive demographic bias right before launch,
Or worse, right after launch in beta testing,
the entire project freezes,
because the legal team steps in.
or the PR crisis management team hits the emergency stop button, the deployment stalls. Millions of dollars are locked in a useless, frozen asset.
And your competitive advantage is lost because you have to spend the next 6 months forensically tearing the model apart to figure out where the bias was encoded.
The text is making a hard operational argument here. Ignoring responsibility isn't a shortcut to shipping faster. It is a guaranteed mechanism for project failure.
Which leads to the ultimate thesis statement of the presentation. The text states clearly, this all fits into our belief at Google that responsible AI equals successful AI.
It is a complete synthesis of the moral and the financial. An irresponsible system is a broken system.
Because an AI system that causes harm, or a system that users fundamentally refuse to trust, is functionally worthless, regardless of the elegance of its code.
Absolutely worthless.
So we understand the massive systemic risks. We understand the B2B economic imperatives, and we understand the need for responsibility by design.
We have the theory down.
But let's look at the human reality of a Tuesday morning in a tech company.
Yep.
You have a team of highly intelligent, highly opinionated engineers, data scientists, and product managers sitting in a conference room looking at a new feature.
A recipe for conflict.
Exactly. Half the room believes the feature is a bold innovation that will optimize a massive workflow. The other half believes the feature is excessively invasive and crosses a privacy line regarding user telemetry. How does a massive organization actually resolve that tension without paralyzing the entire company?
Well, the source text transitions from the theoretical principles to the actual governance mechanics required to run a company. It states that product and business decisions are made through a series of assessments and reviews.
The bureaucracy.
Yes, this is the bureaucratic reality of responsibility. You need formalized structures designed to instill rigor and consistency.
Rigor and consistency across vast product areas. Because an AI feature being developed for a consumer smartphone app in California needs to be scrutinized with the same fundamental framework as an enterprise healthcare tool being deployed in Europe.
Exactly. The text notes that everything begins with assessing whether a project aligns with the overarching AI principles.
Yeah.
But it also provides a heavy dose of reality, which I appreciate.
What does it say?
It explicitly acknowledges that not everyone will agree with every decision made about how products should be designed responsibly.
I think this is perhaps the most pragmatic insight in the entire framework. It dismantles the utopian idea that having a list of principles magically generates perfect consensus.
It doesn't. When you are dealing with probabilistic technology intersecting with highly complex societal norms, reasonable experts are going to have profound, intractable disagreements.
The principles don't eliminate the argument.
No, they don't.
So the source material offers a structural solution to this human friction. It says, this is why it's important to develop robust processes that people can trust. So even if they don't agree with the end decision, they trust the process that drove the decision.
That is the key.
I want to really examine that dynamic. How does process replace consensus?
Well, consensus requires everyone to change their mind and agree on a single truth. In complex ethical engineering, that is often impossible.
Right.
Process, on the other hand, requires transparency and structural fairness. If an engineer raises a red flag about a potential bias vulnerability in a new model, they need to know their concern won't just be ignored by a product manager eager to hit a deadline.
There has to be an established pipeline for that concern.
Exactly. It might go to an internal review board composed of legal, ethical, and technical experts.
A neutral body.
Yes. The board evaluates the threat model, cross-references it against the company's stated principles, and makes a documented, transparent ruling.
And the engineer who raised the flag might still fundamentally disagree with the final ruling. They might still believe the feature is too risky.
But if they know their concern was rigorously evaluated by a neutral body, according to an established framework, they can accept the operational outcome.
The trust in the structural integrity of the process absorbs the shock of the personal disagreement.
Beautifully said. Yes.
The text notes that establishing principles is a starting point rather than an end. And I love this specific phrasing. It says principles rarely give us direct answers to our questions, how to build our products. They don't and shouldn't allow us to sidestep hard conversations.
The friction isn't a sign that the governance is failing.
The friction is the governance working.
Exactly.
Yeah.
The principles just build the arena where the hard conversations are forced to happen before the code is deployed, rather than happening in a panicked boardroom after a public failure.
It forces the human value judgments out of the shadows of individual coding decisions and into the light of institutional review.
Which is exactly where they belong.
Which brings us to the final segment of our deep dive. The text concludes by outlining the 3 concrete pillars that actively govern Google's research, product development, and business decisions.
The ultimate distillation of the framework.
Right. Let's deconstruct them, starting with Pillar 1, bold innovation.
The text defines bold innovation as developing AI that assists, empowers, and inspires people. It is meant to drive economic progress, enable scientific breakthroughs, and help address humanity's biggest challenges.
It is deeply significant to me that boldness and innovation are listed first in a framework entirely dedicated to responsibility.
Why is that significant?
Because when we talk about AI ethics, the conversation is almost exclusively dominated by fear. It's about slamming on the brakes, restricting access, and mitigating disaster.
True.
But Pillar 1 asserts that failing to innovate is also an ethical failure.
Oh, absolutely.
If this technology has the potential to model complex protein folding to cure diseases or optimize global supply chains to reduce emissions, then we have a responsibility to push the boundaries of what is possible. Responsibility does not mean operational paralysis.
But that mandate for aggressive progress is immediately checked by Pillar 2, responsible development and deployment.
Ah, the counterweight.
Exactly. The text acknowledges that AI is a still emerging transformative technology that carries evolving complexities and risks.
And this highlights the central tension of the entire industry. How do you simultaneously execute Pillar 1 and Pillar 2?
It's the hardest balancing act in tech right now.
How do you sprint toward bold scientific breakthroughs while carefully auditing your systems for evolving complexities? It requires an organization to operate with split focus, one eye on the theoretical limits of the technology and the other eye on the immediate threat models of deployment.
The source text explains that this tension is managed by focusing on the life cycle of the product. It states that responsibility must be applied from design to testing to deployment to iteration, learning as AI advances and uses evolve.
The operational key here is iteration, right?
Yes. In traditional software, you might ship a final version and move on to the next project.
You burn it to a CD and you're done.
Right. But in AI, deployment is just the beginning of the observation phase.
Because the model will encounter edge cases in the real world that the engineers never conceived of in the lab.
Precisely. The system must be instrumented for continuous telemetry when the AI encounters an evolving complexity or exhibits an unexpected behavior.
The engineering team must be able to detect it immediately.
Pull the model back, iterate on the safety parameters, and redeploy. It is a continuous, closed-loop system of bold innovation followed by rigorous calibration.
And that operational reality points to the final concept, Pillar 3, collaborative progress together.
The text defines this as building tools that empower others to harness AI for individual and collective benefit.
This feels like an acknowledgement of the sheer scale of the technology. A single enterprise, no matter how vast its resources, cannot contain or fully secure the entire ecosystem of artificial intelligence.
No, it's impossible.
Well,
The objective is not just to build proprietary models, but to build and export the security frameworks, the auditing tools, and the responsible design methodologies so that the broader global community can interact with the technology safely.
because a massive vulnerability in one corner of the AI ecosystem eventually degrades the baseline trust for everyone.
A rising tide lifts all boats, but a toxic spill ruins the whole harbor.
Exactly. Okay, let's step back and synthesize the enormous terrain we've covered today.
We covered a lot.
We did. We started by looking at the ambient invisible AI that already routes our traffic and curates our media. We shattered the persistent illusion that these systems operate as autonomous, objective oracles.
We discovered that they are, in fact, incredibly powerful optimization engines that are entirely downstream of subjective human decisions.
We examined the mechanical threat models of that reality. Because these models are trained on historical data, they inherently up the flaws of society.
And because of the scale and speed at which they operate, They possess the terrifying capability to mathematically amplify subtle human biases into impenetrable systemic barriers.
We analyzed why a simple static checklist cannot secure a dynamic, probabilistic technology. Instead, we explored the necessity of embedding responsibility by design.
Shifting the ethical evaluation to the very beginning of the engineering life cycle and focusing on the core pillars of transparency, explainability, fairness, accountability, and privacy.
And we established that this is not merely a philosophical exercise, it is a harsh business imperative. In the B2B enterprise landscape, transitive trust is the ultimate currency.
An AI system that acts irresponsibly will shatter that trust, leading directly to stalled deployments and massive financial losses.
Responsible AI is the foundational requirement for successful AI. And finally, we saw how organizations manage the inevitable human disagreements that arise from these complex decisions.
They don't rely on perfect consensus. They build robust, transparent review processes.
They balance the absolute moral imperative to drive bold, world-changing innovation with the rigorous, iterative demands of safe deployment.
The most vital takeaway from this security engineer's framework is that the machines are not in charge.
The humans are. The humans designing the cost functions, selecting the proxy variables, and managing the review boards hold the ultimate authority.
It always comes back to us.
Which leaves me with a final provocative thought for you, the listener, to carry with you. The source material makes it undeniably clear that deeply personal values and subjective choices are hard-coded into every layer of this technology. The data it considers valid, the societal context it respects, the variables it ruthlessly optimizes for, these are all the echoes of human decisions. As these systems continue to scale, quietly managing more of our logistics, filtering more of our information, and advising more of our crucial decisions, whose specific values are you actually interacting with when you query an AI? When you look into that digital interface, expecting the cold, calculated objectivity of a machine whose beautifully messy, inherently flawed, and profoundly human reflection is actually staring back at you.
Wow. That's a question to keep you up at night.
Thank you for joining us on this deep dive.